Now we're going to look at an application of propositional logic to the field of artificial intelligence. There's lots of different things that you can do that would be considered artificial intelligence. And one of the ways people test the different approaches to artificial intelligence is to apply those to simulated worlds. And one of the more famous simulated worlds is called the Wumpus World. Okay, and I've shown you an example right here. So the way it works is this. We start in a particular cell, in this case 1, 1. And we want to navigate by moving up, down, left, or right within the world here until we can find the gold. And once we find the gold, we'll pick up the gold and then try to find our way back to an exit. But the problem is that there's some dangers along the way. One of those is the presence of one or more wumpuses. So if there's a wumpus in a cell, then it will produce a stench in an adjacent cell. So we can see here there's a wumpus in cell 3-1, and it produces a stench above it, to the right, and below it. And had there been a cell on the left, it would produce a stench there as well. There are also pits in the world, and they generate breezes to let us know that they're nearby. So we can see here for the pit that's in cell 3-3, it generates a breeze to the left, to the right, above and below. So how do I use that knowledge to help me move safely through the world? Well, let's say that I were to move up to cell 2-1. And the reason I know it's safe to do that is because I don't feel a breeze or smell a stench in cell 1-1. So I know I can safely move up or to the right. So I happen to move up. When I move up, I smell a stench, which means there has to be a wumpus above this location, to the right of this location, or in the cell that I came from. And we already know it's safe because I'm still alive. But I still don't know whether or not there's a wumpus above 2-1 or to the right of 2-1. So if I were to move back down to 1-1 and then move to the right to 1-2, now I can determine there's no stench here, which means there cannot be a wumpus in cell 2-2. Had there been a wumpus right here, it would have produced a stench here as well. But when I moved to cell 1-2, I felt a breeze, which means there's a pit nearby. And so just like before, that means there must be a pit in 1-3, or there must be a pit in 2-2, or there's a pit in 1-1, which we know is not the case since we were just there. But earlier I had been in 2-1 and did not feel a breeze. Therefore, I can rule out 2-2. So as I move through the world, I pick up these additional facts, places where there's stenches or breezes, and then also places where there is not a stench or not a breeze. And that allows me to make certain observations about the locations of a wumpus or pits. So we start with these initial facts. B prime means there's not a breeze in cell 1-1. There's not a stench in cell 1-1. There's not a pit in cell 1-1, and there's not a wumpus in 1-1. What I'm going to do now is use rules from propositional logic to start in cell 1-1 and then show that I can safely navigate to cell 2-2. You may think, wow, that's not very far, 1-1 to 2-2, but as we'll see, it takes a lot of rules of propositional logic to get there. As I move along, I will pick up additional facts. If I were to move to cell 1-2, at that point I will determine there's a breeze. I don't know it when I start off. I find it out when I get here, and then I will make observations. And likewise, if I move to 2-1, I'll find out there's a stench. So I'm picking up these additional facts, and I also know certain things about how the world works. I know, going back to the original Wumpus World I showed you that was 4x4, I know there will be a breeze in cell 3-2 if and only if there's a pit in cell 2-2, 3-3, 4-2, or 3-1. That is the 4 adjacent cells to to cell 3-2. So remember how the biconditional works. It says if there's a breeze in 3-2, then there must be a pit in one of these cells, and if there's a pit in any of these cells, it will lead to there being a breeze in 3-2. And likewise for a stench, it's a biconditional, so if there's a stench in 2-1, if and only if there's a wumpus in one of these 3 locations, and things like that. So don't want to read all this to you. I'll let you read it, but I'll leave it on the screen here for a moment. And then we'll go through some of the propositional logic rules to show how I can get to 2, 2. All right? So these lines here, every 5 lines statements, I put a line just to make it easier to figure out what we're looking at. But I start off with knowing there's not a breeze in cell 1-1 and there's not a stench in 1-1, so these are hypotheses. I also know a fact about the world, and that is if there's a breeze in 1-1, then there must be a pit in one of these adjacent cells, and likewise, if there's a pit in one of these adjacent cells, then there must be a breeze in 1-1. I can take this and replace it with the equivalent statement, which is the 2 implications, and then I can pull one of these out using simplification. Given that I know that if there was a pit in 1-2 or 2-1, there would be a breeze in 1-1, and I know there's not a breeze in 1-1, then I can use modus tollens to conclude that there's not a pit in 1-2 or 2-1. I then use De Morgan's to show that there's not a pit in 1-2 and there's not a pit in 2-1. Then I can extract those 2 additional facts using simplification. All right? While I'm still in cell 1-1, I can use the fact that there's not a stench there to make similar observations. So if you look at the lines, if you look like at line 3 and line 10, you can see the rules that I'm using are the same, or at least the propositional logic rule, right? Here I'm using the biconditional. I then expand it in both cases. I then use simplification to take part of it, use modus tollens on that part, and so forth about 1-2, right? Then I can take a couple of facts I just picked up, not P12 and not Wumpus 1-2, to show that it's safe to visit 1-2. Going up above, look at our world. Here's 1-2. I use the fact that there's not a breeze here, there's not a stench here, and my understanding of the world to show that I can safely move to 1-2. That's what I just did. So it took all of that, 19 steps, just to show that I can visit 1-2. And so we'll sort of pretend that I've now moved there. When I do, now I pick up an additional fact, which is a hypothesis, and that is there's a breeze there. Now I'm going to take my knowledge of the world about what a breeze there means, which means there has to be a pit in an adjacent cell, and I'm going to do something similar to what I did before. Take the biconditional, turn it into a conjunction of implications, pull out part of that, take certain facts, and show that I can visit 2-1. Right? And I'm going to repeat this over and over again. So you'll notice, like I said, similarities where I'll take, when I get to a certain location, I'll do basically the same things at every location to show a new safe location to move to. Keep working my way down. And by the time I get to line 47 here, I've now shown it's safe to visit 2-2 because there was not a pit in 2-2 and there was not a Wumpus in 2-2. Now, could you shorten this up some? Maybe, but I try to be very explicit here in showing what I'm doing, because some of these facts I don't really use, but I'm producing those along the way as needed. But all of that, like I said, was to show that we can move from 1-1 to 2-2 safely. And if you worked on a much larger world, I'd have even more steps because, I'd have to show I could get, for example, to 2-1. But now there's a stench, so I'd probably move back to 1-1. Then I move to 1-2, show there's a breeze. From here, I would know that there's probably a pit here because I've already been here and there wasn't a pit. Then I could move to 2-2. Then I could move either up or to the right or whatever. And that would take much more than the 47 propositional logic steps. So what are some other things we could do at the Wumpus World? Well, I've also done examples before, or I've worked problems where we use statistical approaches. So, if you move here and there's a stench, then that gives you certain probabilities of there being a Wumpus. And as I move around, I can find, the probability of a Wumpus being, here, for example, might be different than the probability of a Wumpus here or whatever. So like I said, there's lots of different approaches to artificial intelligence that could be used here, and I took a class where we did that. But this was an example of applying propositional logic.